Hello, everyone. March 21st, new town hall. We got a lot to do today, so let's get into it. Up first, if you look, for those core contributors to IFT, if you look in the town hall channel, I have kind of the rundown of all the links and what we're going through there, so you can open that up and check and watch it as we go. And if you want a link, it shall be there. And I think afterwards we'll get presentation links to all the slides here and add those as well. So go there for new stuff. And up first, IFT or announcement. So we're going to bring Angel on first to talk about some new joiners and some anniversaries.
Nice. Hey guys, hope everyone can hear me. So yeah, I'm just gonna be going through new joiners and anniversaries. So for the Nomos team, we've got quite a few people. We've got Andres, Antonio, Nagib, Chris, and Petar. So welcome them to the team. Then for Waku, we've got Jazz, we've got Vin, for Vac, we've got Radoslav, we've got Vlado for Vac as well. For finance, we've got Nacho, Ashen coming in at finance as well. And then for the comms, we've got two people, we've got Jules and Nenad. Insights, we've got Matthias, and then Claire and Nick as data engineers for the infrastructure team. So welcome everyone. And then anniversaries, there's quite a few. 8th anniversary, Andre and Ricardo. You guys have been with us for ages. Jacek, Richard, Yuri, Andrea, and Eugene, 7 years, damn. Pepper for 5, nice. Frank, Rachel, Jordan, Ned, and Brian, 4 years, nice one, guys. 3 years of Katia, Noelia, Pedro, Daniel, Kay, Daniel S, Alicia, Patrick, Pavlo, Pavel, Campo, Maya, Siddharth, and Jesse. Nice one, guys. And in 2 years, relatively new here, Alexander, Marcio, Santi, Francesca, Guru, Rotislav, Ulysses, Alvaro, Ben, Adam, Martin, Jakob, Christian, Moody, Ivan, and Dee. And then for the 1 year anniversaries, we've got Helena, Marina, Agnish, Advaita, Pedro, Benjamin, Tanya, Sean, Andre, Noel, and Philip. So yeah, well done, guys. Thanks for joining and thanks for staying with us. And if I butchered your name, I apologize.
8 years, man. There's only a few left that are older than me.
Like, as props, I want to give a little. I had a little noise for the people, but it's not working. Okay.
Oh, let's get some speakers out. All right, man. Thanks for coming on, and thanks to everybody who's been with us for so long. Here's to more and more years. Keep going. All right. Thanks, Angel. Let's get on to some more stuff. Appreciate it. I have another announcement. So, I don't know, a couple months ago, I put on a proposal for a $60 a month expensible budget for AI services, which was approved and added to the handbook. So, if you're interested, you can use AI and you can expense it for $60 a month. Where we go from here is probably to build some space somewhere in the organization where we come up with best practices, ideas, useful tools that you can use to help leverage whatever you're doing. Because like how you use AI to leverage your job is differentiated based on what you do. And how much you trust AI to do that is also differentiated by what you do. So we should probably make a space to talk about that, give tips, tools, whatever for various things. So if you have any ideas there, hit me up. There is an AI ML channel in the Logos Discord. So go there. That's a good place to start. And then we'll build some best practices and resources for everybody over time. So go use AI, $60 a month. Now we can get into the content here. First off, we're going to go with Juan. I'm going to talk about a few things regarding some NIM releases. We've been wanting some NIM language related changes and we're getting them. So I'll bring him on to start talking about those.
Hi, can you hear me?
Yep.
Okay, perfect. So I will be talking about the major improvement that we have done into Nimble, and then some small improvement that we did for the VS Code extension. But bear in mind, this is not all of what we have done. We don't have enough time here to cover those, but we will be for sure in the future, right? So starting with Nimble, the biggest single major improvement was the SAT solver. Before, Nimble was using a legacy a greedy solver, which is it can today be activated using the legacy flag. At some point, we're going to remove it entirely. But basically, a greedy solver has like the notion only of the local scope. So when you try to, for example, for this project here, when you try to solve the dependencies using the greedy solver, it will fail, and you will see why in a moment. This is actually, by the way, an issue that was on the Nimble repository. We have a test passing today in our continuous integration using the SAT solver. But essentially, let's say that project A requires this B version, right? And then this other C. How the greedy solver will work is that it jumps into this dependency here, and when it reads, okay, this B dependency depends on any arbitrary C version, right? So this will go to C then, and it will have to make a choice between the 0.1 and the 0.2.1 version. By default, it always picks the latest one. So since it doesn't have like a global view, it only has like the local scope view, it will miss that later on when it backtracks to the beginning, it will fail to match this constraint. So even though the dependencies are well specified, it will fail using the greedy solver. On the contrary, the SAT solver has like a global view, and it can see all the dependencies straight away and all the constraints, and it takes all the constraints into consideration before making the decision, right? So basically, this is like the advantage of using a SAT solver. For those unfamiliar, it's pretty much what I just said. And then we also have this other overlooked feature, I think. Not many know about this. One of the reasons why we started to work on this is once we introduced the SAT solver into the community, a lot of projects started to fail because they were like improperly tagged. And I think within status, we also suffer that problem. So the thing here is that the SAT solver tries to solve the last one solution. And if it fails, because the solution is not possible to be satisfied, because let's say, by the way, this is called iterative version selection, right? I have an example here, it will be easier to see. Like, imagine this A package requires this B version, right? And then when picking this C2.1 fails, because maybe this C package also depends on another higher B version, and it will be like a contradiction here because we are fixing the B version to this via A, right? So it can satisfy this constraint, but we have here a relaxed C version, right? Because it's any C version. So the solver will iteratively try with the next possible solution. So essentially what this does is first it fetch n number of versions, but the 4 is 4, that matches the constraint specified, and then it starts trying to solve the solution iteratively. Like if it fails in the first step, but then there is still a solution space, it will attempt to use that one, right? Yeah, and this basically are the advantage. Okay, moving on to the new stuff. This was released this week. It's still on experimental. We made a release so library authors can start testing it, but we are introducing a declarative parser. As you might know, the way that Nimble file works, we use the NimVM to parse them and to extract the requirements. Let's say the syntax still remains the same with the new declarative parser, but we don't do evaluation, need evaluation anymore for the parse stage. Then later on, when we fully load the package, of course, we keep doing VM evaluation. So the task and such keep working, right? But for getting the requires of or the dependencies of a given project, we don't do NIM evaluation anymore, which speed up the process by a lot, because we have to, with the SAT solver, we have to evaluate every single version of every dependency upfront. So spinning up the VM for every single package is quite a bit. So there is no need for that anymore. And then we can also have deterministic dependencies, which in the future will allow us to write a reliable caching. And we say that we have deterministic dependencies because with the NimVM parser, you could use the when closure to a compile time require something or not. So depending on the state of the world, in different execution may have different requirements, which in the real world, that doesn't happen too often, but you know, there is that potential edge case. We need to do better, right? So in order to support conditional dependencies, we are adding the feature block, similar of how the feature block works in Cargo. So yeah. For example, let's say that we have a library that can have multiple backends. As you know, there is like the STD backend, async dispatch, and then the Chronos library. So if you want to support both, you may want to only install Chronos if the package really uses it, right? If let's say you are going to use the async dispatch backend, well, you will install Chronos. That's like a waste. So with feature, we can achieve that. And basically, here we are creating a feature called Chronos that basically requires the package Chronos, right? When enabled, the solver will, of course, take the Chronos into consideration, right? So there are two ways of enable feature. For the current package, you will use the flag, like passing the feature that you want to active as a parameter to Nimble. But let's say that you depend on that package and you want to use the package inside your project rather than at the project level, activating a feature at the project level. So you will do you will use this operator here, right? And it is of course a set multiple package by comma separated. There is documentation in the Nimble guide about this. Then in the Nim code, you can check when feature is enabled by following this convention here. This is only execute a compile time, remember, the when statement, and then you can do, if this feature is defined, then import Chronos, otherwise import async dispatch. So that's quite handy too and convenient. And finally, we introduced the Dave feature, which will be activated for the current development, for the current package in development. Basically, until now, if you require unit tests, you will ship unit tests, which may not be what you want, right? Because you only want it like for internal development. And so that's why we are introducing the dev feature. So you can put the requirement for development in there, right? Of course, since this is gonna be used, we introduce an alias, which is pretty much the same thing for it. Moving into the small quality of life improvement in the VS Code, there is this propagate section that was implemented a while ago in Suggest. Until recently, it was propagated via Avail in the England server. But for the VS Code extension, we are intercepting it when something like this write file here emits an exception. Instead of getting an annoying vel that sometimes gets in the middle, even becomes an actual character, we do an underline here, and I can show you in the filler in the Nim code editor itself how this works. So since this is propagating an exception, it gets highlighted, but you can go into the.
Can you make that a little
file.
bit bigger? That text is kind of small.
Yeah, let me view.
Control plus.
Yeah, I don't know why it's not working. I think
Control plus.
Yeah, no, it doesn't work like that. Let me go to here. I think it may be changed. I don't use this computer. Yeah. So okay, it's equal, right? Okay, it's better now.
No more.
Okay.
There we go.
Now? Okay, perfect. So this is from the STD. This write file definition. If you look at it, it has this propagate exception as well on write. So it gets propagated through write file. So that's why we see it here, right? But you can keep going further. You will see that at some point it uses this rise AOE IO. And then at some point it is actually rising an exception, right? So it gets propagated all the way up into the code and finally appears here. Okay, and then the other thing is that we have better Nimble integration with VS Code. We now do, like, when you start a Nimble project, we do Nimble setup for the current project if not done already. We support syntax highlighting in the Nimble files. And also we do support, we also detect the task that a project can have. This is, by the way, the Nimble file for the function. As you can see here, you can run the task from this button here, and they also list in the Nim panel tab. Okay. Lastly, we also work in this setup on Nimble action. This is for a quality of life improvement in the continuous integration side of things. Usually, when you set up a Docker file for Nim, you will need to install Nim, and then install Nimble, and then install your project. Now, since we have worked in Nimble being able to manage to work without Nim, let's say, and download the Nim that it needs, we created on top of that this action, set to Nimble action. Basically, this is, by the way, an example for the England server. This is how it is defined in its continuing iteration, but this is pretty simple. Basically, you can define here the version, optionally the folder where you want to download it, and the version is just the number, latest, or recently we added the nightly too, so we can test things out. But yeah, basically this is the repo. Yeah, and this is like this the different options that it has, if anyone is interested. Anyways, I will be sharing these slides. If one wonders how this is created, I mean, it's not super, it doesn't look super fancy, but it's actually an Nim library that a member of the community did. It's called Nim Slide, in case someone is interested in this as well. But anyways, I will be sharing this slide as it is. That's pretty much it.
Awesome. Thanks, man. Excited to see a bunch of the NIM specific features, adding some quality of life stuff.
Cool.
From what I understand, many of to take advantage of a lot of these things within your project, you need to be building with Nimble. That's correct?
Yes, of course. And that's one of the goals that we have as a team, is to be enable that all status projects that use NIM are able to be just user Nimble. So that's why we are bringing up all of these features. It's driven by the necessity that status has in their projects in order to get rid of the Nimble build system scripts and just use Nimble. And we are getting there.
Awesome. What do you see? What's next on the horizon? What are you working on?
So on the Nimble side of things, we need to fix a few issues that we have. There is also this idea of making local the default package and then calling it Nimble 1.0 once we are able to build a package like Nimbus using exclusively Nimble. On the VS Code and inline server side of things, one of the next features that we want to implement is the test runner. So you can run your tests within the editor as you could with pretty much any other language today, right? So the goal is to get NIM into a state where the tooling is on pair with all the mainstream languages that there are out there.
Love that. Thanks a lot for coming on and telling us about some of the updates.
Thank you.
For anybody who wants to keep up with this or give feedback or raise issues or just keep track of things, the NIM channel, which I think is bridged across all of the Discords, is a good place to go. Is there anywhere else you'd like people to follow or go to or keep up to date with?
Yeah. I mean, if you want to be updated with the NIM community and what's going on with NIM, the NIM forum is a great place because all major announcements go through there. And also there is, if you are more into the details of how things are going and what's the status of the compiler and all of that, the Discord channel internal is pretty good too. But yeah, I would say NIM forums is a good place to start.
Cool. And the link for this Nimble release is in the town hall page as well. So I'll add the slides, but that forum post is already in there. Okay. Thanks a lot, Juan.
Thank you.
All right. Coming up next, we have Marcin to discuss some ongoing work with the Codex BitTorrent integrations. So let's bring him on, and here we go.
Hey guys. So last week you had a chance to hear a presentation from Giuliano about performance metrics and comparing Codex protocol against BitTorrent. This week I'm going to tell you a bit about our current effort of actually bringing support of BitTorrent protocol to our Codex client. So on the radar today, I have why we actually doing this. I will shortly recap with you how BitTorrent actually does discover content and shares content, so that we understand how to do that, how we do that in Codex. I will then show you how actually Codex BitTorrent extension can work like. It's still very much work in progress, but it's already functional at this stage. I will wrap up with what's next and some handy links. And if we have enough time, I will even maybe be able to show you a small demo how it feels like. So let me start with why we want to bring this old, almost forgotten by many, perhaps, technology back on stage. Well, still BitTorrent has users, and there are communities that use BitTorrent. And we want to see if by supporting BitTorrent, maybe we can actually bring BitTorrent users to Codex. And the best way to bring BitTorrent users to Codex is to make sure that BitTorrent content is available on Codex, and even more importantly, we are able to fetch the same BitTorrent content from Codex using native BitTorrent identifiers. So, but that's not the only reason, actually. When we look at BitTorrent, we still continuously improve our protocol, and looking at BitTorrent and learning bits and pieces, how they approach things, especially when they upgraded from very early version to DHTs to version 2 of BitTorrent protocol. They have learnings behind, and from these learnings, we can also learn something ourselves and perhaps improve our own Codex protocol by looking into this. So as I mentioned, the challenge is, and that's actually the trickiest part, is how to actually use BitTorrent content identifier and be able to fetch the same content on Codex. So basically, if you're a BitTorrent user and you have a torrent file, which I will just explain in a moment, if you have a torrent file or magnet link, you would like to use that same link as an input on Codex client and be able to get the same content if it's already seeded, of course, if it's already uploaded to Codex network. To understand how this potentially could work, I will first start with recapping a bit about how actually content is discovered on BitTorrent, and from this direction we can kind of understand better challenges and how it could work with Codex network. So normally you have an input which is in torrent dictionary and file. In this presentation, I will limit our focus to files, and I will purposely also limit our attention to torrent version 1. We are plans of supporting version 2, of course. It's actually even easier. Version 1 is more challenging to support on Codex. But on the same time, what we see that version 1 of torrent is still much more widely used than version 2. So actually covering version 1 seemed to be more important than covering version 2 at the very beginning. So you have dictionary of file, let's say file, you want to seed that. So basically this file will be converted to a torrent file, which is a BitTorrent manifest file. This torrent file is distributed around usually in B-encoded form, which is a machine readable string that you see an example here for example file. And below I have equivalent of this B-encoded torrent file shown as a JSON, basically, so you can see what kind of things are there. The most important things, you see the announce. This is the URL of the tracker, which I will just be talking about in a moment. And we have info dictionary, which describes the content, its length in this case, because this single file, the name of the file, the piece length, which is the abstract size of the exchange unit on BitTorrent network. And you have very important attribute pieces, which contains hashes of every piece of the content, which we'll also see how important it is. This info dictionary, only this info dictionary, is also then B-encoded and hashed. And this hash, called info hash, is the actual handle of the content on BitTorrent. And so we want to be able to use this same info hash to fetch the same content from Codex once it's there. So now we have I said we have input as a file. This file is cut into pieces. You see that every piece is power of 2 and at least 16 kilobytes. And then we have a blocks native unit that flows over the wire, basically. And blocks in BitTorrent are 16 kilobytes. So as I said, from this file, pieces and blocks, we get the manifest that describes that, the metadata, and we get an info hash. And what happens traditionally in very early BitTorrent is that there was a centralized tracker that was serving get peers requests, where every peer.
Real quick, it's asked if you can zoom in a bit.
Oh, okay, yeah. Yeah, sorry. Yeah. So every peer in the swarm could contact tracker to request the peers that are also in the swarm and also interested in the same content. So you were sending basically an info hash to the tracker with your own peer ID, so the tracker could orchestrate the swarm and make sure that things are being available to other peers. And later, when DHT tables has been introduced to BitTorrent, what we see that the role of tracker has been replaced by a DHT, basically. So you were no longer dependent on one centralized peer orchestrating the swarm, but every peer in the swarm could ask, hey, give me the peers for that info hash from DHT. And then the peers could just use the protocol to exchange information with each other, also get the torrent file information and so on. Other protocol extensions has been introduced to make it possible. But basically over years, BitTorrent migrated from tracker-dependent swarms to tracker-less swarms. So what they don't need tracker really anymore. And now if we, sorry, if I have to zoom this out a bit. I zoom it a bit too much. So now if we look, let me give a moment. Now how this behaves in Codex on the other hand, so I will be zooming this in a moment. So in Codex, we also have file as an input, or as a blob, or like a piece of data as an input. We do more things than BitTorrent natively do. We immediately introduce Merkle tree. We compute a Merkle tree for all the blocks for that content, and we compute a tree CID, content identifier, which is the root of that Merkle tree. By the way, Torrent version 2 also introduces Merkle tree, but it's not present in version 1. And from that content that we want to make available on Codex Network, we also have a manifest file, a Codex manifest file, which has a number of attributes like content size, again, and block size, for instance. Like you see, similar to BitTorrent, which had like piece length and the length of the content, we also have similar attributes. But we also include a tree CID, so the content identifier of the Merkle tree. And with this Merkle tree and manifest CID, we are actually able to discover the content. And how does it work? Works in Codex, to remind to people who don't know those details. Basically, the first thing you are doing, you are actually requesting the manifest, the Codex manifest. So you see the difference. We could also send the Codex manifest out of band, like basically share it with someone. But in our case, the Codex manifest is also advertised on DHT. So any peer in having a manifest CID can request what are other peers that has that content. And now once you have that list of peers that can potentially provide you with the manifest, you fetch the manifest, and you again, from the manifest, you can get the tree CID. So this content identifier of the Merkle root, and you can start querying DHT. Now give me the peers that actually have blocks that are related to that Merkle tree, to that content. And this happens here basically. So the peers in the swarm then are asking, sorry, this is a mistake here. This again here is also getting blocks basically from getting blocks from other peers, providing tree CID as an input, and in exchange you are getting blocks. So this is basically how Codex does it. So we see there's actually, if you would be able to see this all in one screen, you will probably be able to see there are lots of differences. Here we have DHT tables. We use some kind of identifier to discover stuff. So looks like there are things that looks very similar, yet of course at the protocol level things are different. We cannot just reuse our DHT to use BitTorrent directly. So how we combine these two things? So you notice that in Codex we have a Codex manifest file. This Codex manifest file allows us to decouple kind of the actual identifier for the blocks belonging to the content from the metadata, and we take advantage of it. In our approach to integrating Codex and BitTorrent, we introduce another level of indirection. We are introducing like one extra metadata file, which will be describing the torrent content. So how in our case it works, though, so that the peer that has a content does not publish on DHT manifest CID and tree CID as we did, if you remember here, as we did in Codex when we only advertise manifest CID and tree CID. In BitTorrent, we'll be advertising also a native info hash. So appears in the swarm having info hash, the native original BitTorrent info hash can now query our DHT and ask which peers potentially have the content related to that info hash. And this content related to that info hash will be the torrent manifest file. And torrent manifest file is described here. It includes, as I said, it will have info dictionary, but additionally, we include in this info manifest file a Codex manifest identifier. So original Codex manifest CID. So the peer that retrieves torrent manifest now can look into info dictionary, can be encoded that info dictionary, hash it, and compare it immediately with the info hash from the request. This way we know that we're dealing with the same info hash. But at the same time, we include the link to like content identifier of the Codex manifest. So from that now on, we can start doing regular Codex job and just request from DHT again peers for manifest CID and later peers for the peers, basically. So we can get the blocks for the manifest CID. And from that manifest ID, we again will get the tree CID, and we will be getting blocks. This again, mistake here, it should be get block. We will get the same regular Codex blocks as we normally do. There's one more challenge here that is important to mention. So by encoding info dictionary ourselves, we can and hashing it, we can validate that info hash match the info dictionary from torrent manifest. But for Codex manifest CID, theoretically, someone could put a fake CID content, and someone requesting BitTorrent hash would be getting completely irrelevant, forged and wrong content, basically. But we prevent this from happening, basically, by knowing that every piece, we can hash it ourselves. When we aggregate the blocks that we receive through the Codex protocol, we build like higher layer in which we aggregate all those blocks in the pieces. And once we get the piece, we can hash the piece. And now we can compare that hash with the hash which we can find in the info dictionary, which is in the torrent manifest, which we know by now that includes correct info dictionary. So by doing this, we can actually very flexibly serve a BitTorrent content on our network. So before I will maybe, it looks like I may be able to show you a very quick demo, but so I will switch to terminals. I hope they are visible. Are they big enough? Like, you don't have to see much details because there will be not really a lot, but it would be nice if you...
but the text is a bit small.
Okay, so I can still try to enlarge that a little bit. And so what happens here, I'm running two instances of Codex client. On left terminal and the right terminal, you see two terminals. Now, on another terminal, I will be now generating a 10 megabytes a file, basically. And I will be trying to first upload that file to one of the clients. And you can see I can do it. I have somewhere here it is. Just very regular Codex API, similar to Codex API. We just added new API for uploading torrent. So if I execute this, you see that something was flying around. You see the manifest being described here and pieces and hashes of those pieces. But the most importantly, this thing returns to us a multi-hash with this piece in the multi-hash being exactly original BitTorrent info hash. This will be the same info hash that people normally would get in BitTorrent. Now I can use that info hash to get that content, basically. So if I now very quickly export that info hash, and now let me get that content back. So now I'll be fetching that content, but for another node. So they have to connect and have to discover it. So you see, I'm getting the content back. I could run OpenSSL to show you that the hashes matches, but believe me, they do match. There's exactly the same content. We can also conveniently I get a manifest, the torrent manifest, so you can actually see the length of the content, which corresponds to 10 megabytes, the piece length that we use, 256 kilobytes, and you see the pieces, the hashes, and you see at the bottom the Codex manifest CID that has been used to actually get the content. And what is nice about it now, if I show you a very last thing here, is that you can actually, by using our original Codex, original Codex API, in which we just do data instead of torrent and instead of info hash, if I now paste here the content identifier, and I should be able to actually get the very same content natively as Codex content without any overhead from BitTorrent, which means that the moment that we see the BitTorrent content to our network, it also becomes natively available as Codex content without any reference to BitTorrent anymore. And that's kind of nice, and maybe we'll find some interesting use cases for that as well. So to wrap up, what's next? What are we going to do after that? Because there's quite a bit of things in play right now. So first, we do need to support files and dictionaries. That's the very first step. We want to support full version 1 BitTorrent protocol. Then a low-hanging fruit, as I said, actually supporting BitTorrent version 2 is slightly easier because our inclusion proofs, Merkle trees, and things are very similar, so it's actually less obtrusive. By doing this, actually, we want to add some nice extensions. So, in BitTorrent, you can publish dictionary, but you only can get the whole dictionary. You would like to see if we can provide ability for the clients to actually only download selective single file from the published whole dictionary content. And then we would like to see if we can integrate our extension, so BitTorrent Codex protocol, which will be probably published as a library with one of the open source BitTorrent clients. We already look on a number of clients. I think one of the potential candidates would be QBitTorrent or Transmission. And then we'll see, because it's all like exploring. We are happy to see what it gives us back, if this has any potential. If we find this doesn't make sense anymore, we stop, basically. So we will be observing feedback and looking what we can do next with it. So you can later check the links. This whole presentation is also nicely available under this Excalibur link. You can zoom in now nicely and see all the details on your own pace. We have extensive documentation about BitTorrent, learning BitTorrent, BitTorrent documents, and how to integrate that with Codex. And this is a living document which is continuously updated. There's also published version that you can browse without using Obsidian Vault. Obsidian Vault is very handy. So you just can clone that repo, open it in Obsidian as a vault, and you have complete searchable documentation on everything that is recorded there. And there's more and more things coming there. And if you want to get in touch with us, there's Codex client team where I'm now directly working with, and me, myself, MC2, CET on Discord. Yeah, that will be it. Thank you.
Awesome. That was great. Look, it's really neat that you found a way to kind of add the flexibility of BitTorrent into Codex, while also just serving the files the same way, but accessing them in different ways, which gives you basically a lot more exposure to the torrent system without having to alter Codex itself, right?
Yeah. I mean, one of the challenges was also we do want to support BitTorrent, but we do not want to come with Bulldozer into our Codex protocol. So the kind of one of the objectives was to not to damage Codex protocol too much. We can enrich it and add features inspired by some things from BitTorrent, but we won't keep things easily separable in a way.
For sure. Jesse was DMing me during that presentation, mentioning like the drastic differentiation in downloads between V1 and V2 of BitTorrent. I didn't realize that. Like the older version still has the vast majority of content there.
Yeah, they may be differences, and most importantly, well, the reason they introduced version 2 was that they discovered the problem with version 1, of course. So in version 1, for instance, as you can maybe already realize, the soonest moment when you can start validating content when you aggregate pieces in BitTorrent. Piece is the native unit of data exchange in BitTorrent, not block. And they have very small blocks normally, like 16 kilobytes. And pieces are usually much larger. For large content, the piece can be 4 mega even. And then before you aggregate piece, you actually cannot say anything about the content if it's valid. In version 2, you can start validation on a block level. They have number of protocol extensions that allow you to query peers for inclusion proofs down to block level, and you can be much more flexible with that. Also, the metadata has been significantly reduced, especially if you have many files. In version 1, that was a headache, actually. If you have lots of files and the same long folder structure, you could have a big torrent file. And they handle it much better. They use also tree structure right now for version 1. But otherwise, actually, lots of things in the protocol remain very much similar. The exchange messages are the same. While the big change, of course, is SHA-2 is now the standard for version 2 of BitTorrent. But they do it in a clever way, in such a clever way, in a way that you can forms the peer that is searching for content can join swarms for both version 1 and version 2, and take advantage of blocks coming from both swarms at the same time, which is quite powerful, taking into account that lots of content, it's easier to find content still on version 1.
Another comment from Samuel here in the comment section. We don't have too much time, so if you can address that pretty quickly, we'll move on to the next presentation.
Yeah, I mean, the things related to value proposition, this is something that we are open to think together with everyone in a way. So yeah, if people have ideas, please talk to us, basically, because this is for us also to some extent unknown how to effectively bring BitTorrent use. So there's lots of different thoughts and issues about it. I purposely do not talk that much about it because I wanted to focus on technology behind, but it is a challenge, of course, on its own.
Great. Well, as you said, you gave your contact info here. Go to the Codex Discord from chat. Hit me if you can't find any of those, and we'll
there's also torrent integration channel on Codex client team. If people can access that, then there is also something you can reach directly, join discussion directly there as well.
Thanks a lot, Martin. That was great.
Thank you.
Up next, we got about 10 minutes. We may go a little bit over, but we've got Jazz coming on to talk about some of the chat research going on.
Hello. My name is Jess. I joined Waku this month, actually, as the chat research lead, namely focusing on how can we build decentralized protocols that kind of solve a little bit more of the app layer side of things. As a background, I've been working in Web3 messaging for a few years now. I came from XMTP, where I was a senior staff engineer focusing on, how do we solve this problem for developers, creating messages that work around. And so I'm excited to be here. It's, the status Waku IFT side of things, really focusing on that privacy side. And today I'm kind of looking to give you a little bit of an overview of what you can expect from chat research, methodologies and how we might kind of roll things out. And so I think it's important to start with what is chat, or what is chat research going to focus on? When we think about chat, it's more than just passing messages between people. There's indications of identity and permissions. How do we manage multiple devices and chat histories? It needs to be reliable and fast, recoverable if there's a compromise. There's a lot of nuance that's there rather than just getting a message from A to B. And that's where chat research is namely going to focus on, is how do we solve these problems in order to support developers to build so that they don't necessarily have to kind of keep diving in and solving those problems themselves. There's only currently 2 chat apps, Status Mobile and Desktop, but there's still a strong need for decentralized solutions here. And so, yeah, chat research's focus is going to be largely on how do we solve these across problems with like kind of 1 foot in Waku and 1 foot in Status, kind of solving it from both sides. My goal is to kind of be a champion for app developers on the Waku side and make sure that everything's kind of working from top to bottom. And so you might ask, how are we going to do that? My big approach here is, we need to align on what the goals are. Nothing shocking here. Define where the boundaries are going to be so we can have clear separation of concerns. That's really going to help out from a protocol layer where we can focus on making sure that everything's covered from top to bottom and what properties we're getting by using certain composable protocols. Step 3 is to kind of build an infrastructure for the future where we can kind of grow and move easily. And then the next steps are, how do we get beyond that? So on the Align side, the core issue is that we all have different ideas of what security and privacy are. And that makes it really hard to have discussions around it when we all have different assumptions. I can propose this bank vault example of, is a bank secure? That comes with a lot of assumptions around, do we trust the employees? Is the state someone that we trust or not? Has it been built to a standard that we trust a lot? We can get absurd here and also say, are we considering comets and asteroids in the security model? Because that really changes about what might happen. And so to kind of have an agreement on all these things, we need to kind of have them written down. And so, the first step there is to kind of make the implicit things explicit through defining a security model and a privacy model. I've really appreciated working within this framework to ensure that every conversation is rooted in kind of the same background. We can always go back to the security model or the privacy model and actually see what's happening on each item. And so there'll be lightning rod models up Monday for anyone who wants to kind of weigh in, because I think this is the first step. This is where we get to kind of share our beliefs. I don't think that we'll all agree necessarily on what those values should be, but this at least gives a framework to kind of talk about it and get to a common understanding. Security model is going to answer questions like, if your account is compromised, can you recover it or at least notify your contacts? Do we offer protections against quantum-based attackers? The idea here is to get real clear on what's in scope and what's not. After we've kind of defined, the general goals and what we're going to consider as our problem space, the next question is how we get there. There's this ongoing problem of what layers of the protocols are responsible for what properties. Right now, Waku and Status are very tightly coupled, with Status Go kind of being in the middle. There's this real mixture of kind of app level concerns and more like chat focused protocol concerns. And when they're all mixed together, it's kind of hard to kind of move forward. And so by defining clear layers, we can really work on that. And so the goal here is to make sure that we know exactly where our properties and functionality is coming from. And so that means defining a clear transport layer. In this case, the diagram showing Waku with a delivery, routing, censorship resistance. What do we get from the transport layer? Then we move up a layer of abstraction. We think about these sessions being built, packets being put into authenticated streams. And so we have encryption and authentication and, contact discovery. And then lastly, the role is, what are apps like Status that build on top? What are they required to do? What's in their sphere of responsibility? And the goal here is just clarity, making sure that everyone knows what's going on. We can kind of think about this in a different capacity of where do we put or who should be responsible for things. And so I'm kind of proposing this idea here where, Waku's in charge of things that affect or require all peers to coordinate. The chat layers responsible for things that require all chat apps. And then apps on top can get to pick what's best for their users and their user experiences. And really delineating that around a center of concern will help us move forward on where things should be being solved. The key here is coordinating between layers and understanding exactly where our properties come from. after we've kind of defined, we aligned on what we needed, we defined the landscape and responsibilities. Next question is, how do we kind of put this into action? And right now, the problem is that making any updates or improvements, particularly at a protocol layer, is difficult. From the bottom side, it's really hard to gauge impacts of changes. What in Waku has significant or critical impacts on the apps that are there. We don't want to see any degraded performance. And then also from the top side, with status go being tightly coupled into Waku and other things, we're really blurring these layers of abstraction, which makes just general audits and reviews very difficult. And so the path forward here is to kind of isolate chats into a reusable chat SDK and kind of go back towards these first principles. This makes sense from a protocol specification point of view. It makes sense from an auditing point of view, where we can remove kind of the user, the app level concerns from the protocol, so that we can be super clear about what's happening there. My view is to kind of try to add clarity by making sure that we're having complete coverage. I want to be able to answer exactly where forward secrecy comes from, or are we resistant to different attacks. I want to make sure that that's super clear. We know exactly what property it's coming from. Particularly when we start thinking about protocols in a composable way, it's important to have that kind of leverage. And so by isolating one-to-one chats in a reusable SDK, we can reach for parity. We can define what's there and going to work for us in this kind of new model of separation of concerns. And then, kind of decouple from a very classic approach to, modules and making sure that we're not blurring abstraction lines. And then, the next question is, how do we grow? Where do we go from this first step once that one-to-one chats are kind of dialed up? And this is an area that I'm super excited about. I'm not trying to put the cart before the horse, but I'd like to lean on my previous work on MLS to see large efficient group chats in status. MLS is a technology that is gaining a lot of traction for its just pure efficiency for particularly group chat. But most importantly, I think the ideas are going to come from the developers building on top of chat. So what's needed to kind of make this work? How do we build safe and engaging user experiences? And that's kind of the call out today is, if you got thoughts, let's chat. I'm always down for a good chat. I want to make sure that we're aligning kind of the protocol side and serving the people who are building on top of it. So I'm on Discord. Come over and say hi in the Waku chat or the Waku server, and we can kind of kick off these conversations.
Oh, I've got lots of thoughts. We don't have too much time to go through them. By happenstance, me and Oscar, previous core contributor, used to be the head of VAC, and I guess you could say founded Waku. Me and him made a sock paper on the old Whisper / Waku protocol. I sent that to you in DM if that's useful for you as you start to kind of
awesome
narrow it down, add a security model and privacy model, things like this. I don't know if any of that stuff will carry over to how it is today, because I know things have changed both within status and within Waku, but maybe there's some help there.
Yeah, I think understanding what is in place and why it's there is super important, but then also carving out a pathway to the future where we get to make gains in the areas that we need to. Making sure that the identity model matches, making sure that we're getting the properties that we need and everything's kind of tightened up. So any context is super helpful.
For sure. I probably have more stuff. I'll send it over as we keep going here. That's the hour. Thanks again. That was great. I very much look forward to seeing some of the products of this effort come to fruition. I love the idea of people making alternative clients that are compatible with status, widgets, so on and so forth, that people can interact with on websites, or as it says, on various layer 2s that you can use. You can still chat to within status, stuff like that. So welcome. Glad you're on board.
I appreciate the welcome.
All right. Thank you. So that's all the time we have today. But as always, I have included in the town hall document that is published, and we'll also put it in the description of this video, is a number of posts that we did over the past week. We didn't have too many blog posts, but one of them was really a large one, which is the release of the new status version, which adds base, new keycard flows, new onboarding flow, and a new fiat to crypto on-ramp, amongst other fixes and so on and so forth. So go check that out. Go download it. Tell your friends to get it. Click on the links, show your friends, as well as all the other posts there are that are in there. Also, I did all the forum posts. There's a number of really good forum posts and continuing of communication we've talked about earlier. Go click through them, interact with them, share them, etc. And a couple podcasts, which we did over the past couple weeks. So go watch those and like, subscribe, tell your friends. Thanks, everybody. See you in a couple weeks.